Hello, everybody. Good evening from my side. Wow, it's so interesting to see how many ideas there are about the possibilities of micro-LED technology, mini-LED technology. So for me, it's really interesting to see. I also appreciate the discussions we already had during the first day of this conference already. My name is Christoph Appel. I'm the responsible product manager at Delo for LED applications in general. And so I think you will all agree when I say the big question now is, how can we make these great ideas you all have become real? Especially small first series. So in the beginning, when you start with a small series, customized applications, the processes are highly expensive at the moment. So how to overcome these hurdles? How to turn the ideas into reality here? How to keep the invest also low? And this is where Delo wants or tries to make a contribution here. So we are developing and producing industrial adhesives, so glue actually, right? And not a glue you can buy in a typical workshop, not a normal glue, but really high-tech adhesive for high-tech applications. So just to give you a feeling about what I mean with high-tech adhesives. So when you look on your smartphone, for example, bondings of the camera, sensors, speakers, in such high technology purposes, this is our focus. And especially for the mini-micro-LED market, we developed a directional conductive adhesive, short DCA. So this means this adhesive will not only bond two parts together mechanically, it also does that, but also it's electrically conductive itself. Plus, it is not conductive in any direction, but only in the direction of the connection you need it to be. So in the connection between, in the direction of the patch of the dies to the substrate. And how is this done? So this small simulation shows how it goes. So in magenta you have the adhesive, and in there are electrically conductive particles, filler particles. You press the dies down to this filler particle size, and then you get, by this mechanical contact, the electric conductivity in the direction you want it to have. In between, there will be no risk of short circuits because the density of the filler particles is so low that there is no conductivity in between. And also, so the adhesive is then cured by heat. So you press the LED down to the filler particle size, and then you heat it up, and then the adhesive is cured. And what we also think of as a maybe next step is that you can illuminate the rest of the adhesive with UV light, so you can then fix it with UV light so that the dies will be in place and will not move anymore. To test our adhesive and to show that to prove the feasibility, we developed a test board. You can also see at our booth and have a closer look on that. And so these tests showed you can really bond, in this case, mini-LEDs. So we used like 100 to 200 micrometers edge length LEDs to bond them to this PCB board. No soldering process was involved, and we hope that this is like an advantage. So when you think of decreasing LED size, the conventional bonding technologies like soldering come to its limits, and maybe we can contribute here, giving an advantage. So this really shows it works. We could also do reliability tests here, and for example 85 tests, storage tests. And here you can see how it was actually done. So we